sine hyperbolic inverse t is now 1 upon 1 plus x, 2 upon 1 plus x minus 1. That will be 2 minus x minus 1 minus x. That is 1 minus h. In the numerator it will be 1 minus x upon 1 plus x. This is the value of sine inverse and hyperbolic inverse. Let me write it. Value here. The value, finally, this value is here. So this is minus sine minus 1 upon 2 sine hyperbolic inverse 1 minus x upon 1 plus x. Why? Because in place of t we have 1 upon 1 plus x. By substituting we have 2 upon 1 plus x. 1 plus x LCM will be minus 1 minus x. That means 2 minus 1 minus x means 2. 2 minus 1 is 1. 1 minus x upon 1. Plus constant k. Let me take constant c here. This is the final answer. These two sine hyperbolic inverse are not similar. They sound finally answer. This is question number 19th. Okay, so question number 19th is done. Let's talk about 20th question. Now question number 20th, let's check what kind of question it is. And question number 20th is the last one. Okay, this is to be rationalized. Question number 20th is in the root 1 plus x plus x square 1 under root x plus 1. So whenever numerator is with radical sign like this, we have to rationalize the numerator. So rationalizing numerator means we have to remove the square root. For that, we have to multiply the numerator by the same value and denominator also. If I multiply this, we can write it as 1 plus x square after removing the radical and divided by the same value 1 plus x square dx. What we have done? Nothing. We have multiplied numerator and denominator by the same value. If I multiply numerator by the same value, square root will be cancelled out. The denominator will have the same value 1 plus x plus 2x square. Now if I divide the numerator by this value separately, as we just did in question number which one? 19th one. The single value will be here. If I divide this by x plus 1, we will get here by multiplying x square plus x minus sign. Both cancel out. Only one is the remainder here. X is the quotient. Okay, x is the quotient. It can be written as x plus 1 upon x plus 1 multiplied by 1 plus x plus x square dx. It can be written as x upon under root 1 plus x square into dx plus minus integration 1 upon x plus 1. We change it under root 1 plus x square into dx. Now it is divided into two parts by multiplying this square root value. Now this is there. Now here we have to by inspection we can do what 2x plus 1. If I write 1 upon 2, which is 2 plus 1. If I add here minus 1, we can do plus 1 minus 1 change. Now it can be divided into two parts. 1 upon 2, 2x plus 1 upon under root 1 plus x square dx. Minus sign is 1 upon 2. Sign of integration dx upon under root 1 plus x square. Okay, these two can be integrated easily. The sign of integration for this value is 1 upon x plus 1 under root this is 1 plus x square into dx. This I will integrate separately. Let me first integrate them. These two are integrated as. Let me write them here. The first integration is simple. What we have to do, we have to put the value 1 plus x square as t. Okay, or t. This will be t here. So twice x plus 1 into dx into dt upon under root t. It will be, that will be 1 upon, an integration will be what? 1 upon under root t is equal to, that t can be taken in the numerator, t is for minus half, integration of t is for plus half upon plus half under root 1 plus x square upon half. This half cancelled out. This integration is done completely. Minus 1 over 2. It can be made as perfect sphere. So it is nothing but x under root. It will be x plus 1.2 whole square plus sine is 1 minus 1.4. Why? Because 1.2 whole square is 1.4. We have added 1.4 here in these two terms to make it perfect square, and we will subtract 1.4 also. So 1 minus 1.4 is 3 upon 4, that means under root 3 upon 2 whole square. So this is done. Plus sign of integration, this I will take it now. Under root, this is 1 plus x square. What we will do? By substituting x plus 1 equal to 1 upon t. So in this substituting, these two are integrated. So now in this case, putting, because t I have not taken yet, let me take this x plus 1 equal to 1 upon t. So therefore dx equal to minus dt upon t square. In this case, now this integration is, we have done nothing but 1 plus x square minus 1 upon 2. So this is integrated x square plus a square type. Sine hyperbolic inverse. This sine hyperbolic inverse twice x plus 1 upon root 3. Twice x plus 1 upon 2 upon root 3 upon 2 to cancel out and root 3. Plus in this case we have substituted this value. Then minus dt upon t square upon this is 1 upon t, but x plus 1 is 1 upon t. Under the square root, one value, 1 upon 1 plus x. Sorry, x is 1 minus 1 upon t minus, plus this will be 1 upon t minus 1 whole square. Okay, so let me now do it. Finally, these two steps are same. Let me do this. These two are similar. Finally, we substitute this value. Now this is minus dt. Now t square will be removed. Why? Let me take this is 1 upon t. From square root t square, we will take t square as simple. T will come out from square root also. This t square. Let me write here t square. We multiply this whole by t square. It will be t square. Okay, this is also, but plus 1 minus 1 cancel out. I'm sorry. Only t will be there. Sorry. This will be only t. This is t here. Because if I multiply this by t square, taking t square as LCM, okay, this will be plus 1 minus t upon t square. I am taking 1 minus t whole square is 1 minus 2t plus t square. 1 minus t whole square we have opened here. Finally, this t square will come here. This will come out as t. This and this. This is minus sine dt upon under root. This minus t only. It will be t square minus t plus 1. Okay, so this again can be written as dt upon under root sine t minus half whole square. This is minus 1.2 whole square. Okay, that means 1.4 we have to add here, subtract. It will be again under root 3 upon 2 whole square. Because 1 minus 1.4 is 3 upon 4. 3 upon 4 can be written as root 3 upon 2 whole square. Same value. And this is t minus this value t square. We have we have to divide by 2 the middle term, so 1.2, that means 1.2 whole square we have to add in this equation. We have to subtract 1.4 also, and this d square minus d plus 1.4 is this d minus 1.2 whole square, but this 1 minus 1.4 is 3/4, that is written like this. Finally this is integrated. What is this? X square minus plus a square, that means sin hyperbolic inverse. Let me write here the value of sin hyperbolic inverse. Finally the answer of this equation is answer here. What is that? It will be sin hyperbolic inverse minus sin. It is minus sin here. Okay, sin hyperbolic inverse. So this is 2t minus 1. 2t minus 1 upon 2 upon root 3, that will be 0. This is root 3 and I'm sorry, this is plus constant. This is the final answer. Okay, but still we have to substitute here. What is the final answer? We write again. This is 1 plus x square minus 1.2 sin hyperbolic inverse. Sin hyperbolic inverse 2x plus 1 upon root 3 minus sin hyperbolic inverse. This value, this will be 2 upon 1 plus x, because t is 1.1 plus x. We have 2 upon 1 plus x. Now 1 plus x will come here. That will be minus 1 minus x. 2 minus 1 is 1. 1 minus x upon under root 3 into 1 plus x plus constant of integration. This is the answer here. The final answer is this. This is question number 20. Okay, we are in the question number 20 now. Let's talk about next question. Question number 21. What is question number 21 say? Let's talk about. Question number 21 is of what kind? Let me check. Question number 21. 21 is this question. Question number 21 is okay. Question number 21. 21. This is sign of integration. Okay. 1 plus x plus under root 1 plus x square. Right. 1 plus x square divided by, this is 1 plus x minus sin under root 1 plus x square into dx. Whenever this kind of question is coming, you have to rationalize the denominator. The denominator is to be rationalized. Okay. Then what is the answer here? If I rationalize this equation, it will be, okay, if I rationalize this, we have to multiply this denominator and numerator by a minus b. This is a plus b. That is, by we have to multiply this by a plus b means 1 plus x plus under root 1 plus x. Okay. Let me rationalizing rationalizing the numerator and denominator by multiplying by multiplying the numerator and denominator by the multiplying the numerator and denominator. Okay, rationalizing by multiplying the numerator and denominator by 1 plus x plus under root 1 plus x square. We have to multiply by this value. We get, now in the numerator you will have whole square of this, the same value. It is nothing but 1 plus x plus under root 1 plus x again whole square of this. Okay. Divided by this will be 1 plus x whole square minus sin it will be 1 plus x square only. Okay. This is ds. Okay. If I take it in this way. So it can be separated into 1 plus x upon 1 plus x this and under root. Okay, it can be separated also by written this in two parts. So this can be written in two parts. This upon this and this upon this value. So then 1 plus x, okay, this is similar value type. But if I take separately for this upon this, these two values, then under root 1 plus x upon under root 1 plus x whole value. Okay, so let me check what is coming here. Let's take it separately then. Now it is simple question. This is 1 plus x whole square plus this is nothing but 1 plus x square only plus 2 into 1 plus x into under root 1 plus x square in the numerator. What do you got in the denominator? Let me take the denominator. We have 1 plus x square here is 1 plus 2x plus x square minus 1 minus x square. If I substitute so this is 1 x square this out only upon 2x. Okay, so let me divide each term by 2x. First term is 1 upon 2, let me take common. If I divide this 1 plus x square by, if I open this x square, so it will be 1 plus 2x plus x square upon x only plus this is again 1 plus x square upon x dividing by x because the denominator we have only x. This is also divided by 2 into 1 plus x under root 1 plus x square divided by x. So these are the three separate things. Sign of integration, that is sign of integration into dx into dx into dx. The three steps here. Okay, so after rationalizing this, we have obtained this value because in the denominator we have only 1.2 plus. Here this 1.2 will come with each term. This 2 is cancelled out. Only last term is without any numerical value. Let me write it now here. Okay, this is now simplified. Let me write it here. The first step is 1.2. First is 1.x here, separately integrated. Plus this is 2 and 2 to cancel out. Only 1 will be 1 into dx. First step. This x square upon x is only x 1.2 into x into dx. First step. The second step is again plus 1.2 into 1.x into dx. Plus second step is 1.2 into x into dx. There are certain similar terms. No problem. That will be right. So, plus sign. The first step is if I divided by x, it will be 1 upon x, okay, into under root 1 plus x square. Let me separate them into dx plus sign. Second step will be only under root 1 plus x square. So this is x upon x into under root x square. These are two steps. Now let me take similar steps here. 1.2x, 1.2x, okay. It will be 2 upon 2x, only 1 upon x is there. These two are similar terms. And this is separated. This is also 1.2x, 1.2 is x only. What we write them is this is 1 upon x into dx. These two terms are added, this one and 1.2x, this one. And this step and this step are also similar. This is x into dx, half and half, 1. This is the dx only, this step. Okay, these 5 steps have been written like this. Okay, 1 and this 1 Okay, so these two and these two are become one, so this is okay. Now only these two steps are last one. This is last step is under root. If I take under root the x square, or if I substitute 1 upon x equal to 1 upon t, or x equal to t suppose, or x equal to 1 upon t, then okay, that will be better. I will do this. So let me write here, this is 1 upon x under root 1 plus x square. This I will do separately, but this is simply integrated. What is 1 plus x square? This is 1 upon 2. Yeah, this is 1 upon 2 only. Okay, within bracket x under root 1 plus x square plus a square is 1 only, so sine hyperbolic inverse x only. This is the integration of this 1 under 1 plus x square. Okay, so this is this value 1 upon 2 x into under root this value. Now this is to be integrated separately. This is integrated here. This is plus 1 upon, or let me write here. In this case, let me take x equal to 1 upon t. Therefore, dx equal to minus dt upon t is here. In this case, it will be 1 upon x means t only, because 1 upon x means t. And under root, this will be t square plus 1 upon t. But then dx equal to minus dt upon t square, sorry, that will be means dt upon t square will again come. That is not going to be the difference. Okay, so if I take 1 plus x square equal to something, right, that will be u. That will be done in separate way. Okay, but this is not going to solve the situation. If I substitute, let me take 1 plus x square equal to u square or t square, let me take. Okay, t square. That means x square equal to t square minus 1. Okay, so that means 2x. Yeah, that will be okay. That will be 2x into dx equal to 2t dt. Or this is 2 instead of x dx into d. Now, if I multiply this by x and divide by x, we change. It will be, let me write here, x upon x under root 1 plus x square upon x square into dx. Now it's okay. So what is the final value? Now this is integration plus 1.2. This is bracket x under root 1 plus x square plus sine hyperbolic inverse x. This last step, this is step. Now it is, we have substituted t square, this will be t here, and this x is, okay, x dx is dt, x dx is d dt, okay, so that will be t dt, and this is x square, we can substitute them, okay, so finally we have, okay, now this is what, let me write, log of x, this is x square upon 2 plus x only, this one. Now here we are integrating. So what is the substitution? Now here we have substituted t square. This it will be x into dx is d dt. It is t into d dt. Okay, divided by this is x square, that means t square minus 1, nothing else. Dt we are substituting. Now side one is 1 plus x square equal to t square, that means this is t. X dx is d dt, so this is d dt and t is d dt. Okay, upon t square, x square is t square minus 1. Now it's okay. Plus this last value 1.2 x under root 1 plus x square. So 1.2 sine hyperbolic inverse x only plus constant of integration. Now this is to be substituted and integrated. Finally, it will be log of x plus x square upon 2 plus x here plus let me then t square. T square if I add or subtract 1, is t square minus 1 and t square plus 1. That means t square upon t square minus 1. If I separate them, it will be 1 or dt upon t square minus 1. Okay, that is there. So this is only 1 dt, that means t only. This 2 are cancelled out. We have separated this t square, added 1 and subtracted 1. Subtraction will give the same value. Okay, this is without square. Plus 1.2 x under root 1 plus x square. This value plus 1.2 sine hyperbolic inverse x plus constant c. Now let me write the whole value here. What is this? This is the answer. Log of x plus 1.2 into x square plus x here, plus this value is 1 into dt means t only, plus t is under root 1 plus x square. This is okay, and this is again 1.2a only log of t minus 1 upon t plus 1. Okay, this value plus 1.2 x under root 1 plus x square plus 1.2 sine hyperbolic inverse x only plus constant. Now only this t is to be substituted. This is need to our common type. Let me write it. Log of x plus x square upon 2 plus x here. If I take under root 1 plus x, it will be 2 plus x upon 2, or it is x half x plus 1 2 plus x upon 2 into under root 1 plus x square. These two I have added plus 1.2. Let me write sine hyperbolic inverse. Sine hyperbolic inverse x only plus this value. This is 1.2 log of t here is under root 1 plus x square minus 1 upon under root 1 plus x square plus constant of integration. This is the final answer. I will learn the answer, but answer is okay, 100%. No any misconception here. This is the final answer. Final answer, question number 20. A lengthy question, but simple one. Question number 21. Yeah, let's talk about question number 22. Now, question number 22. Let me check what is this question. 22 is this. Okay, 22. Question number 2. This is under root x square minus a square upon a on x on dx. Yes. Now, if I, in this case, rationalize the numerator, we have to multiply by the same value under root x square minus a square into numerator and denominator. If I multiply by same value under root x square minus a square, we will obtain x square minus a square, which square root is cancelled out by multiplying by the same value on x under root x square minus a square into dx. Okay. Now if I separate it, so first will be, if I divide the first step, will be x upon under root x square minus a square into dx. Let me separate them. Minus sign, this is a square dx upon x under root x square minus a square into dx. Dx we are taking. Okay, now this is standard question. Alright, by dividing x, first step is x upon this value and this. Now, what is this question? If I take this as t, so this will give us 1.2, that is 2x into dx, 1 under root x square minus a square, we integrate minus sign, it is only a square. If I multiply this by x square, x into dx upon x square under root x square minus a square. Then let's substitute this is equal to t square substitution this value. In the second case, that x square minus a square is equal to t square. Twice x dx is equal to dt. I'm sorry, 2 dt, 2t into dt. It will be twice x into dx equal to 2t dt. Cancel out x dx equal to t into dt. Just by differentiating with respect to t, we have obtained x dx and dt. Here it is. Let me write this. This is still problem. If I take x square minus a square equal to u, then 2x into dx equal to du is equal to u only, not u square but u. Then it will be du upon underneath u. That will be 1 upon 2. Under root the same value. This integration is simple upon 1 upon 2. These are explained a number of times. No change. Now this is a square. Now x dx is dt. Divided by x square is t square plus a square. Out of bracket into t. So this t cancel out. Now it is integrated easily. With t square plus a square out of bracket. So here x square is equal to, from this, t square plus a square. T square plus a square in place of x. We have multiplied by x in the numerator and denominator. In the denominator we have x square, and we have x dx is t dt. But this is value t, but x square minus a equal to t square. This and this will be t only, so t cancel out. This is integrated easily now. This is under root x square minus a square. So this is x square plus a square type. It will be 1 upon a. That means 1 upon a only. Then inverse x upon a, sorry, t upon a, I'm sorry. Here it is t only. It is t upon a. Now we have to substitute the value of t. What is the final answer? Let me write here. So t was, we substitute here x square minus a square equals t square. Therefore t by under root of this. Okay, let me write here. This is final answer. Under root x square minus a square, the first value. Minus this is a only, minus a. Then inverse t under root x square minus a square upon a